Hello friends, my name is Abhishek Kumar Srivastava and please watch this video till the end. Please subscribe me and press the bell icon. Today we are going to do the chapter dimensions in which we are going to do the numericals. This is from subject physics of class 11. So in dimensions, so we always write it in capital and in square bracket. For example, dimension of length is capital L enclosed within a square bracket. Then mass, its dimension is capital M enclosed within a square bracket. Time, its dimension is capital T enclosed within a square bracket. So these are the three dimensions of the basic quantities that will be used here in this chapter. Now, first type of numerical which comes in regarding dimensions is to check whether the equation is dimensionally correct or not. So we will do these questions. So I am rubbing the board. So our first question is V is equal to U plus AT. This is our first equation of motion in which we have to verify whether this equation is dimensionally correct or not. If we have to find that this equation is dimensionally correct or not, we have to find the dimensions of each term on the left and right side of the equation, and if all of the dimensions of each term come same, then that equation is dimensionally correct. So now here we will find the dimensions of each term. So the dimension of V is, since it is velocity, so it is meter, that is length, and time per second, so it is t raised to power minus 1. So the dimension of V becomes t raised to power minus 1. What will be the dimension of U? This is again velocity, so its dimension will be Lt raised to power minus 1. And the dimension of AT, A is the acceleration, so its dimension is L, and the second square, so Lt raised to power minus 2 into time, that is t. So simplifying this, it becomes Lt raised to power minus 1. So our equations are, this is the first equation, this is second equation, and this is third equation. From 1, 2 and 3 equations, we can say that the dimension of each term is same in this equation. So it is dimensionally correct. It is dimensionally correct. This is the conclusion that is drawn. So this is how we have to do the questions regarding to find whether the equation is dimensionally correct or not. Now we are going to proceed to the next question. So I am rubbing the board. You can see it here. V is equal to U plus AT. V is equal to Lt raised to power minus 1, since it is meter per second. So per second, so it is therefore minus 1. Here velocity, U is also velocity, so it is dimension is Lt raised to power minus 1. At is acceleration, so it is Lt raised to power minus 2. T is time, so into time. So it is, after simplification, it becomes Lt raised to power minus 1. So from the first, second and third equation, we get that this equation is dimensionally correct. So I am rubbing the board to proceed to the next question. In this also we have to find whether the equation is dimensionally correct or not. This is our second equation of motion, as equal to ut plus half at square. So again we will to find whether the equation is dimensionally correct or not. We will find the dimension of each term. So the dimension of s here is distance, so its dimension is L, length. Ut, it is velocity, so it is L t raised to power minus 1 into time, that is t raised to power 1. So simplifying, plus t minus t gets cancelled, so ut is equal to L, so its dimension is also L. Now half at square, here half is a constant, so it has no dimension, and a is the acceleration, so it is Lt raised to power minus 2, and t square, that is square of the time, t square minus t square plus t square cancels, so it becomes equal to L, so its dimension also becomes L. So from the first, second and third equation, all the dimensions of each term are same here, so this equation is again dimensionally correct. So we are going to understand it once more. We were given the equation s equal to ut plus half at square. Here we have to find whether the equation is dimensionally correct or not. To find whether the equation is dimensionally correct or not, we have to find the dimension of each term, and if they come same, then it is dimensionally correct. So first finding the dimension of s, as here is distance, so its dimension is L. Ut is the second term, u is the velocity, so its dimension is L t raised to power minus 1 into time t raised to power 1. So t raised to power minus 1, t raised to power plus 1 gets cancelled, so we get L. So the dimension of ut becomes L. Now half at square, half is a constant, so it is dimensionless, so we will not write any dimension for this. Here is the acceleration, so it is L t raised to power minus 2 from meter per second square, and time square, so it is t square. T raised to power minus 2, t raised to power plus 2 gets cancelled, so we are left with L. So from first, second and third equation, this equation is dimensionally correct. So now we are going to proceed to the next question. So I am rubbing the board and writing the next equation. The next equation is the third equation of motion, v square equal to u square plus 2as. Again here also we have to find whether the equation is dimensionally correct or not. So first, v square, finding its dimension, so it is t raised to power L t raised to power minus 1 and its square, so it becomes L square t raised to power minus 2. This is its dimension. This is the dimension of v square. Again u square, since it is also velocity and its square, so its dimension will be L square t raised to power minus 2. Again finding the third term, that is 2as, 2 is a constant, so it is dimensionless, so we are not going to write the dimension for 2. The dimension for acceleration is L t raised to power minus 2 from meter per second square, and the dimension of s is L since it is length. So simplifying it, it becomes L square t raised to power minus 2, and again from the first, second and third equations we conclude that the dimensions of each term are same, which is equal to L square t raised to power minus 2. So this equation is dimensionally correct. So we are going to understand it once more. We were given the equation v square equal to u square plus 2as. Finding the dimension for the first term, that is v square. This is square of the velocity. So the dimension of velocity is from meter per second L t raised to power minus 1 for per second, and squaring it, so it becomes L square t raised to power minus 2. So the dimension of v square is L square t raised to power minus 2. Again finding the dimension for u square, this is again velocity, square of the velocity, so its dimension will be L square t raised to power minus 2, same as v square. Now finding the dimension for the third term, that is 2as. 2 is a constant, so it is dimensionless, so we are not taking its dimension. Dimension for acceleration, that is L t raised to power minus 2 from meter per second square per second square, so it is therefore minus t raised to power minus 2. As is the length, so its dimension is L. So L into L becomes L square. So after simplification, it becomes L square t raised to power minus 2. From the first, second, and third equations, we conclude that the dimension of each term v square, u square, and 2as are same. So this equation is dimensionally correct. So I think you might have all understood this. To check whether the equation is dimensionally correct or not, such type of numericals and dimensions. So please watch this video till the end, subscribe me and press the bell icon. Thank you.